So in this video here, we're going to be graphing inequalities. So today, graphing inequality requires us to color. So go find your favorite color highlighter or pencil or marker to color with. If you don't have any colorful pens or markers, just use your pen to color with or pencil to shade with. Totally fine. All right, let's get started with our warm-up here. So let's go back and warm up on a few skills that we did in the very beginning of the semester, where we talked about graphing linear functions or linear equations. So those are the equations that graph lines. And typically when you want to graph a line, you want to look for your slope and your y-intercept. So you might remember us graphing that y equals mx plus b, where m here is your slope and b is your y-intercept that crosses the y-axis. So in this case, our slope here is 3, or you can think of it as 3 over 1, and our y-intercept is -2. So that means we'll go to -2 on the y-axis, which is right here, plot our point. Now, when you graph a line, you typically want 2 points so you can connect the dots and draw the line. So we'll use the slope here to get more points. So we'll go up 3, since our slope is 3, and over 1. So in this case, I hit about right there, and I'm going to connect the dots to make my line. And that's it. So that's how we typically graph a linear function, is we look at the slope and we look at the y-intercept. So what about these weird cases where you just have an x and you just have a y and just a number? How do we graph those again? Well, let's try to jog our memories. Well, for this case here, notice that this is just a 3. There's no x here. So that tells me if there's no x, there's no slope. So this slope here is 0. The best way for me to explain this, if I were to rewrite this equation as the slope of 0 and then x besides it, and then plus 3, this is the same equation. This would just be, if I were to simplify it, y equals 3, because the 0 times x cancel, leaving you with just 3. So if your slope was 0, the x disappears. So that's how I know that the slope here is 0. But that's a lot of information. What I want us to get at is that the y equals 3, or the y-intercept here is 3. So that means I'll go ahead and plot my y-intercept at +3. And because there's no slope, that tells me it's a flat line, meaning it doesn't go up, it doesn't go down, it is just one flat line. Or we call this a horizontal line. Essentially, anytime you have y equals some sort of number, just y equals one number here, that means you're going to be drawing a horizontal line. So anytime you see y and just a number, it's a horizontal line you're graphing, and it's whatever that y value that it's hitting on the y-axis. So in this case, 3. Whereas if you have x equals some number, this is the complete opposite. This is going to be graphing a vertical line. So when x equals some sort of number, you're drawing a vertical line. So let's move that graph over just a little bit. So we're going to be graphing this x equals 3 on the x-axis at x +3. So right here, and we're going to be drawing a vertical line. Actually, let me do it with a blue marker here just to be consistent. And there we go. Because in this case, this equation is representing all of the x equals 3 values. So when the line hits x equals 3, then you can represent all of them. All right, so just as a reminder, anytime you have x equals a number, you have a vertical line. If you have y equals a number, you have a horizontal line. So let's get started with our new concept for today, and that's graphing linear inequalities. So I break it down into 3 easy steps to understand. First off, you want to make sure you solve for, if you're given an equation, you want to solve for y. What that means is try to get it in y equals mx plus b format, where you can see what your slope is and your y-intercept. So when you solve for y, or that means you'll get y by itself. When y is by itself on one side, it's easier to tell what your slope is and your y-intercept, which makes it easier to graph. So Inequalities, just as a reminder, is those signs with the mouth. It looks like an open mouth. So one of the things is that the line is drawn a little bit weird if you have, depending on your signs. So if you have an inequality with a line underneath, you're going to use a solid line to graph your line. Kind of like when you have a equal sign underneath, you always draw a solid circle or a solid dot. Whenever you don't have a line, you're going to draw a dashed line. So whenever you don't have the line or the equal sign, you're going to draw a dashed line. And I'll show you the example using the ones below. All right, and then step 3 is the fun part. It's the shading. And so how you can shade is basically which way the mouth is facing. If it's facing towards the Y, or saying that Y is greater than, so if it's facing towards, that means that the Y is bigger. If the Y is bigger, you're going to shade above. If the Y is less than, or basically the mouth is facing away, that means you have to shade below. And I'll explain why when we get to an example here. So let's try out example 1. Let's do a couple of problems first. Let's move this up. All right, so following the steps here, maybe if I can scroll, can I fit everything all there? Yes. Okay. So step 1, it says to solve for Y. Well, lucky for me in part A, it already has Y by itself. So I don't have to do step 1 here. But I do need to figure out the slope and the Y-intercept because that will help me graph the line. So my slope here is -2. So I'm going to write down my slope is -2, and I'm going to put it over 1 because I can always put the slope over 1. And my Y-intercept is -2. So because the Y is already by itself, notice how easy it was for me to determine what the slope was and what the Y-intercept was. From there, you can graph the points just like you were graphing a regular equation with an equal sign. So I'm going to go ahead and plot my Y-intercept, which is at -2 on the Y-axis. And the slope here is -2 over 1. So that's down 2 over 1. But before I can connect the dots with a line, I have to understand what line do I use based off my inequalities. Well, my inequality here is a inequality that has a line underneath. So I'm going to be using the solid line. So solid line. And that means that I'm just going to connect the dots like I normally would with a solid line. Okay? From here, we're going to do step 3, which is the shading part. So grab your highlighter or your marker here. So I'm going to let's grab like a pink color. I think that would be fun. So with this part here, we need to check which way it's facing towards. So notice that this inequality is facing towards the Y. So it's saying Y is bigger or Y is greater. If Y is greater, take a look at your line here. So think of this line as splitting up the graph. You have this part and this part. Well, it says you're going to shade above the line if it's greater. So I'm going to be shading above this line. Let me do that with a highlighter. There we go. So here's my line, and because Y was bigger, I'm shading above it. Let's try to understand why that's the case. Notice that if Y is bigger, numbers where Y is typically bigger Y values are in the positive region. That's why we're shading above the line, because these are all the bigger Y's. Whereas if I were to shade down here, these are all the negative Y's, and I don't want to do that. So that's why I'm shading above the line, because Y is bigger. And that's how you tell. All right, let's try one more before we end this video. So in this one here, notice how Y is not by itself, and we have to get Y by itself first before we can graph it, or else we don't really know what the slope is or the Y-intercept, and that makes it really hard to graph. So to get Y by itself, move the thing that's furthest away from the variable you're solving, which is the X. So I'm going to subtract X completely off, and that gets rid of it. And so now I have 3y, bring down the inequality, and 3 minus x are not like terms, so you're just going to bring them down. So if they are not like terms, that's a number, that's an x, they're not like terms. You're just going to bring them down. From here, you have a 3, so we have to divide off a 3, and we have to divide it to each term on the other side. So the 3 cancels, y comes down. Wait a minute, do I need to switch the sign? I divided by a positive 3, so I don't need to switch the sign. So I just bring down the inequality. 3 divided by 3 is 1. And this x here technically has a negative 1 in front. So I can think of this as negative 1/3 x. So I'm writing this here as a fraction when I divide because it's a slope. It's a number in front of x. So that will be our slope later, which is why I'm writing it as a fraction. So I can see here that my y-intercept, or hang on, let's write my slope and the y-intercept. My y-intercept is the 1 because it's our constant. It's just our number, so it's 1. Whereas my slope is the number in front of x, so my slope is negative 1/3. So my y-intercept is at positive 1, which is right here on the y-axis. And then I need to graph another point to connect the dots. And so my slope is negative 1, so that's down 1, over to the right 3. So that's going to be 1, 2, 3 right here. Now I'm about to connect the dots. So let's think back to what type of line I would use. Notice how the inequality here is a sign without an equal sign. So this here, if you remember the rules, if you have an inequality without a line underneath, you're going to use a dashed line. So let's go ahead and draw a dashed line to connect. So we're going to dash it. I feel like my line's not very straight. Let me do that again. Oh well, good enough. So once I've connected the dots with a dashed line here, we're ready for our shading. So let's grab our highlighter here. And where we're going to be shading is determined by this equation after we've solved it. So it's saying that y is bigger. So again, if y is bigger, you're going to be shading above the line that you drew because these are representing the y values that are bigger, which are the positive y values, or the values that are pointing to positive infinity for the y. All right, so in the next video, I'll show some more problems from the journal, so stay tuned for that video. Bye, guys.